Hello everyone, and welcome to this third and final component of our course on groundwater modeling. We will keep using the Strumpriet transboundary aquifer system as our main case study, as we've done so far in the previous parts. And this time the aim is to show you how remote sensing can really help us to enhance, improve our groundwater modeling studies. This is particularly true, I have to say, for semi-arid and arid regions where in-situ data monitoring is very scarce, and also on very large basins where it's difficult to acquire in-situ data over large areas. Okay, the objectives of the course are pretty clear. First, I want you to gain an understanding in the fundamental concepts of remote sensing. What is remote sensing and how can we use it in geosciences in general and hydrogeology in particular. I'll provide you with an overview of the many applications that remote sensing can provide for water resources assessment and management. We'll also show you some information and some techniques on how to best access remote sensing data. There's a lot of data out there. We will only see a very small part of this, but beware that there is much more remote sensing data available and that what we can see in the few hours we have together. So it's actually quite good news. You'll be able to do more and keep learning and using remote sensing data for many years, I hope. Fourth, we will illustrate how remote sensing can be processed and transformed into water-related information. And that's really what underlines a lot of this course, is how we move from raw data into information for water resource assessment and management. And as we did before in the previous two parts, I will provide you hands-on experience, I hope, with the Strumpriet case study. So we will hopefully see how things can be used in the real world. As before, this course has the same audience. It's aimed mostly for catchment managers with backgrounds in hydrology or hydrogeology, from beginners to intermediate level in groundwater modeling. I will now present you the course outline. So just a very kind reminder that, as before, this is an online and asynchronous course, so you can follow it at your own pace. We've now completed part 1 and part 2 of the course that were dedicated respectively to first an introduction of the main principles around groundwater modeling, and then we saw how we can build on this simple and robust groundwater modeling with an integrated land surface models and what it brings to the underlying groundwater model for the saturated zone. So that was part 2, and we're now starting part 3, where we see how we can go one step further and bring all this modeling platform, if you want, one notch higher, with the help of remote sensing. So what does remote sensing bring to groundwater modeling? That's the big question we'll be working around for this third and final part of the course. Okay, our course is structured in this way. Well, we're seeing the very brief introduction with an overview of the objectives and the course outline. Then there's a second part that's dedicated to the general principles of remote sensing of the environment. That's the fundamentals of remote sensing, how it works. It's important that you spend some time reading this book chapter here, Sabin's 2007, which is really good introduction to what is remote sensing. Then we will start the first tutorial on Landsat data. I will show you how to download and access Landsat data for free. Then we'll move into optical remote sensing, thermal remote sensing, radar remote sensing, rainfall estimate, and total water storage with the GRACE missions, of course. For the tutorials, as I said before, we'll start with a Landsat tutorial, then we will move on using this Landsat data that we have acquired. We will move on to performing an unsupervised classification, just to give you a glimpse of what you can do with the Landsat data and how you could use it, if you had a bit more time, of course, to progressively build a geomorphology map of the area. And this is important because in regions like the Stampriet, there is a lack of information on the soil type. So if you can have some additional information on the geomorphology, it helps with the groundwater modeling. I will then, with the tutorial, show you how you can access for free again SRTM data, space radar, topographic mission. This is terrific and probably the best topographic data you can have for many parts of the world. We will then use in a subsequent tutorial, we will use this SRTM data to map in the Stampriet the depth to the water table. And this is quite an interesting exercise also for the groundwater modeling. Then I will show you how to access some satellite rainfall data. There are many products, rainfall products. We will focus on one of them with a paper published not by FNUC but by Funk et al. There's a spelling mistake there in 2015. And then we will calculate the SPI, Standardized Precipitation Index, from this data there. And for the GRACE, I don't have a tutorial on this yet, but I strongly advise you to read this paper, which has just been released last year by a colleague of ours, Frédéric Frappard, that used the GRACE data to monitor the evolution of water resources in transboundary aquifers in northern Africa. And as we've done previously, the course will finish with a short series of questions and answers. And if you've answered the three questionnaires at the end of each part, then hopefully you should be able to complete the course and get a certification for this. Okay, I'll see you very soon in the next video.